Okay, so last time we have seen what are different types of planning and their comparison. So we have also seen what is short term, medium term, and long term forecasting. So now we will go to factors affecting load forecasting. So what are different factors which affect load forecasting? So let us start with this is fourth lecture. So what is factors affecting this load forecasting? So I'll write one by one. I'll directly go to factors affecting load forecasting. Are you able to see this? Just confirm. Okay. Otherwise, I will increase the font size. Now, is it okay? Okay. So we'll start with one by one. So how this load for forecasting gets affected? So there are many factors which affect load forecasting, and there are also effects which vary from one area. This is one area. If you look at this area 1 and this is maybe second area, so area 2, so the factors which affect this area will be different from factors which affect this area. So this problem with this area may be different from problem with, so they vary in nature. Okay, so now on what factors they vary, I will just write down. So first factor on which this vary is historical load data. Then second factor is time dependent factors. Time dependent factors. Then third one is weather dependent factors. Weather dependent factors. And last, fourth is random factors. Along with this, we can also classify other factors, just like we had other type of loads, we can have other type of factors also. So all these are what? Historical, time dependent, weather, random, and other. So all these are different factors. So all these factors, what they do, they affect your load forecasting. Getting the thing? So one by one we'll see. First is historical load data. So this historical load data, I'll just move little bit down so that you can see. First factor, let me change color so that you'll understand. First factor is historical load data or data. So this is taken on what basis? On hourly basis. So we have seen this historical data. So any error in historical data or absence of historical data for some period can cause major variation in forecasted loads. So if you don't have this data accurate, no accurate data, historical data will lead to bad forecasting. Getting the thing? Or maybe if data is not present, what will happen? Some arbitrary values assumed may lead to again bad forecasting. Getting the? So this may result in major variation, major changes, which leads to this bad forecasting. So all this without data we cannot do anything. So we require good data. So that data can be only obtained through this historical load data. If we don't have this historical load data, what will happen? We may change our forecast, which may lead to a bad forecasting. Let us go to the second point. This was first point. Then second point was what? Yes, anybody? What was second point? Time dependent factors. Now what are these time dependent factors? So you know that electrical load demand, how it varies? Your load demand varies with respect to time. So this sometimes the variation in load demand is regular, irregular, or it is random in nature. Correct? So these variations are divided as per time of day or week. So what we do, either we divide it time of day or time of week or time of year. Correct? So this irregular variations are occurred during which time? Normally during holidays. So holidays are nothing but one is Sundays, then some festive days. So what happens on this? Sometimes some festivals are not celebrated by everybody, but some festivals may be celebrated by everybody. Everyone celebrates it. Likewise, Sundays, it's very common thing that everybody won't celebrate Sundays, all Sundays. Some of the Sundays they will celebrate, or sometimes it happens that you get a holiday plus a Sunday. So any one of the day you celebrate most of the time, correct? Or you go out, or you watch TV, or you call your friends and celebrate. So that what happens on that day, because of that the load demand suddenly increases, but it is highly unpredictable. You cannot predict that. So load demand is different on these days compared to other days. So even sometimes the load requirement varies with your weather and other factors also. So this time dependent depends on how you will use your time. If you are using your time for celebrations, if you are using, the load demand may change. Correct? We'll move to third point. Third point is what? Yes, third point, weather. Now this, for weather, one main reason behind the load variation is that it affects residential load, then municipal lighting, commercial load. So what this weather affects? This weather affects your residential load, then commercial load, then shops and all, so it's comes in commercial load. And your municipal load comes under what? Other type of loads. This weather will not affect your what? Industrial load. Getting the thing? So how weather affects your residential load and all, we'll see. So for that, to understand this, it is necessary to choose proper weather factor and model their effects. So we have to model all the effects what we see on the power consumption. So we'll first write down what are the effects. So first effect is because of weather is, I'll write it with notation A. A is temperature. So there is a variation in temperature. What is B? B is maybe a rainfall has happened. So temperature change is one, weather change, rainfall is another. Third one is a storm. Fourth one is, yes, anyone? Ice or snowfall. This affects your weather, correct? Then fifth one, anybody, is humidity. Humidity. This also affects a lot. Then fourth one, wind speed. High winds can cause problem. Then cloud cover. Then this happens in Delhi, very famous event in Delhi. Problem with weather condition is fog. Then is visibility. Visibility. Then many we have noted, we'll take last one. So like then precipitation. Etc. So all these are what? These are factors, weather factors which affect your power consumption, correct? So let us also write down a single event. If we take out of this, if we take any one, let us concentrate on this cloud cover. So cloud cover, how does it affect? We'll see. So cloud cover is represented as, I'll write this first point as height of cloud cover. Height of cloud cover. Then second is thickness of cloud cover. Then third one is amount. So cloud amount, is it small, big, correct? And time of occurrence, is it at morning, evening, correct? And last one is, fifth one is duration. See how many effects and sub effects of it. So all this, if you just look at temperature and cloud cover affect your what? Residential, office load, correct? Then transportation load, traction we can say, correct? Then it affects lighting loads, As because of this, what happens, daylight illumination level changes because of cloud. So morning, if 7 it is visible, it is largely possible that 9 a.m. you will get the same light as you have at 7 a.m. So 2 hours you will be turning on your light, correct? So the temperature is main reason. So this was one of the factor. We'll take temperature. So what we'll do is we'll take temperature. So temperature and cloud cover affect what? Your residential load. Now temperature is the main reason behind the load consumption, and relation between temperature and load is how is the nature? It is non-linear. This non-linear nature relation we have seen in many of our circuits and all, everywhere. Wherever there is non-linearity, there is problem. We cannot find out, we cannot predict anything because of non-linearity. You cannot find, if the variation is not linear, you cannot find out the what is the exact solution to this. So this non-linear becomes more complicated if there is presence of humidity. So what we'll do, we'll draw a weather sensitive load versus temperature graph, okay, so that you will understand what is happening actually. So this is your, we'll draw this is one axis, okay, and I will draw another axis here. So now this axis will be called as a y-axis. This is your x-axis. So what is y-axis? Y-axis is denoted by weather sensitive load. And it is represented in megawatts, okay. And what is this? On x-axis we have variation. So variation will be always what? Not time but temperature variation. So this graph is for what? Change in temperature and how our load is sensitive. So what happens? So I'll draw a diagram first. Okay, that's good. Okay, another point. Okay, I'll just use a eraser. So this is a straight line and these are having different slopes. So slope of this is KW, whereas slope of this is KS. We'll tell you what is KW and KS afterwards. So this is graph of weather sensitive load. I will just change color. I will use this color now and I will draw some points here and I will tell you what is this. It's not visible clearly. I want something dark. Yes, this is okay. So this is nothing but these are data points what we have collected, and if you join these data points you get this graph. So this graph is nothing but approximation. So earlier you were not having this black line, you were having only green dots. So what you did, you selected a black line like this. This black line goes through a median of all these points. So this is approximate nearest line to your all these green points. Are you getting the thing? You cannot join this. If you have a graph, if you have 2 points, you can directly join like this, correct? But if you don't have 2 points, you have 1 2 3 4, how will you draw a line? You have to draw a line which will be nearer to this point, this point, this point, and this point. So this line is similar to this black line, whatever you get, you are having it in front of you. And what are these star points? Star points are data points which are collected from actual data. Now after drawing this, let us draw a line, dotted part, this line. So this point on y-axis is called as D0, and on x-axis if you draw the same dot like this, very perpendicular line to x-axis. I cannot draw it here directly. You have to assume it is a straight line, TW and TS. See, this TW and TS are lowest points on your graph. Lowest points means what? Lowest weather sensitive load. And this TW represents what? Temperature. TS represents temperature and D0 represents weather sensitive load. So minimum weather sensitive load is D0. So this is also commonly called as variation of load with temperature, is also called as, it has a very famous name. It is called as weather load model. So it's there in our syllabus. So this is your weather load model. So what is this? Green color dots. I will mention it here. I'll just remove this part. We don't require this. This was for understanding. Okay. So I will mention it here that this, what is this star? Star represents historical data. Then your black line this represents what? Slopes, and or you can write a line. So first you have to draw a scatter diagram showing variation in daily peak load demand with proper weather variable or variable as shown. So most common used variable is temperature and humidity. So on x-axis either you should have a temperature or you can have humidity, any of this. This is common everywhere in world, you will have these two factors. So that's why you can take this. So this technique is called as, so joining this black line, drawing this black line is called as linear regression. I think you studied this in maths, and many of your graphs you have drawn this, because machine you get very different points, you draw a straight line in between, or maybe your electronics you have done this experiments earlier. So this is linear regression, means what? You are fitting a curve for this stars. So what you are doing, you are trying to fit a line in between this, so that this line represents what? Your model, correct? So now if you write equation for this, can you tell me what is the equation? If you write equation for this, we will get W is equal to Ks into T minus Ts. If you write equation here, if you want to write equation here, you can write the equation as W is equal to minus Kw into T minus TW. So this is why this is negative, because of slope it is negative. So this, if T is greater than Ts, so I will write all the equations again, that will show us our weather load model. I will write all the equations again, you can refer, I will share you all this. So if you concentrate on this W is equal to Ks into T minus Ts, or you can write W is equal to minus Kw T minus Tw. So now when is this possible? Ks into T minus Ts. Look at this diagram. So this, when it is possible, when your T temperature is greater than Ts. So that means this area from this point to this point, correct? This area, your T is greater than Ts. For this area, this point to this point, we have written equation minus Kw T minus Tw. How you have how do you get this? You can use y equal to mx plus c type of formula, you will get the answer. So this is T, temperature is less than which value? This value, that is Tw. There is in between region, you can see here, this region, what is this? So I will write equation here is equal to, so slope is how much? Slope is 0. So this is Tw minus, so T is in between this thing, so 0 into, if you write anything here, it will be 0. So this is for T less than Tw, this is for T, W and T. So we have modeled our weather into some equations. So the parameter of model are slopes. What are slopes? First slope is Ks and other is Kw. These two slopes. Okay. Ks and Kw. So entire procedure is called as weather sensitive load forecasting. So all this whatever we did is called as weather sensitive load forecasting. Is it clear? And this is called as I told you, this all is called as weather load model or WLM. So many times a question comes in exam for 10 marks. Okay, so you have to draw this diagram, write everything and explain. Okay, let us go to fourth factor, which is our random factor. So first three we have seen, this is random. So event which affect the load consumption using large errors in load forecasting. So there are large errors. So like as I said that you have a cricket match or you have football match or TV program. So all this are not considered. It causes a random factor which also creates problem. So this occurrence of event is known, but it is difficult to model now. You know that there is a cricket match, but it is difficult to model. So modeling of this is difficult because parameters are too much. You cannot imagine parameters, and which parameters may cause what is very difficult to monitor. This is one example. Likewise, all examples come into this. Say a school holiday. Nowadays, very popular virus outbreaks. You cannot predict. Sometimes they are high, sometimes they are low. You cannot predict a virus outbreak now. So all this leads to what? Random factors. And last factor, take a different page now. We call it as fifth one is other factor. Now what are these other factors? So traffic, you cannot predict a traffic. So high traffic, this is very unpredictable, may cause a problem. This high traffic causes problem. Then second is tariff. Tariffs. So this causes problems to what? Industry. Then third point is you have density of load. Then fourth point is population. Sometimes some area may have a very high population, some population is less. Correct. Then you have changeover from winter to summer. So this transition. So all these are what? Examples of your space utilization by residential, commercial, industrial, agricultural customers. Example here is your lighting. Then different types of capacity substation, economic growth, social growth. We have discussed this all. Then load densities are, equipments are, they differ for different kind of load. Most common load densities are 1500 kVA per kilometer square for agricultural areas. Residential, they are 3 times, that is 4000 kVA per square kilometer, and commercial it is 6000, and for industrial it is double of commercial, that is 15000 kVA. An impact of this, what happens? Historical data should be identified for all this. If you have good historical data, you can do good correlation. So before the use of this selected model, it should be checked for adequacy and necessary correlation. Got it? So all these are what? All the factors which affect your load forecasting. So let us go to next point.